everybody. Welcome to 8.3, Graphing Reciprocals of Linear Functions. This is my first attempt at a video lesson, so let's hope it goes okay. And I will get better, I'm sure, I hope, as I go. So the focus of today is to use the graph of a linear function to sketch the graph of its reciprocal function. Okay, linear function. Remember that just means a line, no big deal. Reciprocal function, though, we haven't talked about before, although in Math 8, you did talk about reciprocals. You may remember that reciprocal is just a fancy math word for flip. So if we're talking about, let's say, 2, the reciprocal of 2 is just a half, okay? No big deal, we're just flipping it, because 2 would be 2 over 1, so that's where the 1 came from. Okay, so in the getting started, it's asking for which values of x is each rational expression undefined. Well, if we start flipping stuff, we have to worry when we have variables on the bottom because we can't ever have a 0 on the bottom. Remember that anything over 0 is a big no-no. We can't do it, okay? It's undefined. We have to avoid that. So it asks for which values of x is each rational expression undefined. And in the first expression, we of course couldn't have x equals 0. If we plugged in a 0, we would have 1 over 0, which would be no good. In the second expression, it would be no good to have negative 4, because negative 4 plus 4 would be 0. In the third expression, I hope that you are recognizing in the denominator that we have a difference of squares. So if you quickly factored x squared minus 9 into x plus 3x minus 3, hopefully you could tell that x couldn't be plus or minus 3, because that's what would make the denominator 0. And in the fourth expression, they've gone ahead and already factored it for you. So the values that would make it undefined would be 1 or negative 3. So this is review. You should already be good at this part. Now we're going to graph our first reciprocal function. So I want you to start by creating a y-axis and an x-axis. Get out a ruler and create an x and a y-axis on your graph. And then what we're going to do is they've already given us some input values for x. We're going to plug them into our equation and get our output or our y values. That will generate ordered pairs, which I can go ahead and put on the graph. Okay, so if I plug in negative 0.5, I'm going to get 1 over negative 0.5, which is going to give me negative 0.2. If I go to graph that, go on the x-axis, negative 5, and then I'm going to change my color here for my graph. So negative 5, 1, 2, 3, 4, 5, and then down negative 0.2. So I'm really close to my y-axis. If I have negative 2, I'm going to have negative 1/2. So negative 2, negative 1/2 will go there. Negative 1 gives me negative 1 because I'll have 1 over negative 1. Negative 0.5 gives me negative 2. 1 over negative 0.5, actually, your number gets bigger. Oops, that's not right. Hold on there. Let's erase that and start over. I'm at negative 1/2, right there. There we go. Negative 0.2 gives me negative 5. Now I'm getting really close to my y-axis. There-ish. Negative 1 gives me negative 10. So I'm way the heck down there. 1, 2, 3, 4, 5, 6. But I'm really close to my y-axis because I'm at negative 0.1. Okay? Try to get as close as possible that you can. Now what happens if I plug in a 0? I'm going to get 1 over 0. That's not good. That's undefined. And I can't graph it, actually. It has to just sit as undefined. There's nothing I can do about that. Now if I plug in 0.1, I'm going to have 1 over 0.1, which is 10. So look at what happened. I was way down there at negative 10. Now I'm way up here at 10. I'm at x is 0.1. Why does it keep doing that? Sorry. Start counting again. 1, 2, 3, 4, 5, 6, 7, 8. There. I'm just really close to my y-axis. 0.2 gives me 5. There-ish. 0.5 would give me 2. 1 gives me 1. 2 would give me 0.5. And 5 gives me 0.2. Really close. All right. So even on the smartboard, I'm quite challenged, as you know, at drawing graphs, but I'm going to attempt my best to connect my points. So it's a curve, remember, it's not going to be a line. There's no way. And so, okay, could you, let's try that again. This part. Try it again. Needs to sort of hug this y-axis. And then up here, kind of hugs, flares out, and then hugs my axis again. So doesn't that look weird? Doesn't look like anything we've seen before. But that's the graph of a reciprocal function, 1 over x. Okay? So we don't want to create ordered pairs every time. That's a big hassle. It takes quite a while. And the graph of y equals x can actually be quite handy. So the graph, the graph of y equals x can be very handy in graphing 1 over x. Because I'm going to draw the graph of y equals x for you. I'm going to draw it in purple, just like I drew it here. So the graph of y equals x, no matter what x is, so is y. So my ordered pairs, if x is 0, so is y. If x is 1, so is y, etc. So it's a line that has its y-intercept at 0 and its slope is 1 over 1. Looks something like that. So if I get out my line tool, is that still in purple for me? Nope. There we go. So that line of y equals x looks like that. Okay. So notice what it has in common with the reciprocal. The reciprocal's in red. Y equals x, sort of like the normal if you want to think of it, is in purple. It looks quite a bit different. Look at how the original, y equals x, is a straight line. The reciprocal is broken into 2 parts. Why do you think it's broken into 2 parts? And look at what they do share, however. They share this ordered pair. This ordered pair is at 1 and 1. And this ordered pair is at -1 and -1. That's the only thing they have in common, those 2 ordered pairs. But notice that the reciprocal in red and the original in purple are crossing each other. They're intersecting each other at 2 points. That actually happens every time, and that's really important to remember that idea, okay? So if we continue on here, it says that recall that the reciprocal of a number x, as long as x isn't 0, is the number 1 over x, okay? So if we have the number, any number, the reciprocal is just 1 over that number. And then it says, well, what if we have an equation, so a function? So if we have the function, let's say, of, I don't know, what, come on. Oh, why does that keep doing that? We have y equals x plus 1, for example. The reciprocal is just 1 over x plus 1. That's all it's like, okay? So then it goes through an example here, and it says, well, I'm going to go ahead and graph y equals x minus 1. So they've graphed it in green. And from the equation of y equals x minus 1, here's your y-intercept at -1, slope's 1 over 1. And there we go, okay? And then it's like saying, well, here's the reciprocal, and they've drawn it in red. And it looks quite similar to what we just did. So the red is broken into 2 branches. And look at how the original green and the reciprocal red are intersecting each other. They do that every time. And where they intersect each other isn't a fluke. It's actually important. They are intersecting each other here and here. Okay? This ordered pair is 2 and 1. This ordered pair is 0 and -1. Okay? That's important, and they do that every time. They're going to, the reciprocal and its original are always going to intersect each other. Okay, so here it says, first of all, that the reciprocal is never going to have an x-intercept, okay, the red. It's never going to cross the x-axis because there's no way that you can't make this equation, oopsie, I don't know why I did that. You can't make this equation 0. There's nothing that you can plug in for x that will make it 0. If you plug in 1, you're going to have an undefined expression, and that's not 0. So nothing will make this equation 0. So it's important to know that the red is never going to cross the x-axis, okay? And then it says that the x-axis, therefore, is going to be a horizontal asymptote. Okay, notice this has been added right here. Asymptote. Sounds like a swear word, it's not. Okay, horizontal asymptote, because it's a horizontal line that the graph approaches, but it never touches. So see how the red line, remember I called it hugging the line or approaching the line? It comes close, but it never touches. And then this red line over here on the right side approaches, but never touches it. That's driving me crazy. I wish it would stop that. Okay, so we have a horizontal asymptote, and you know what? We also have a vertical asymptote. Okay, so it says here that the line of x equals 1 is a vertical asymptote. That is a vertical line that the graph approaches but never reaches. Up here, the red line is coming close to x is 1, but it's never going to touch it. And down here, it's coming close, but it's never going to touch it. Well, where did this come from? It came from that undefined value. So up here, I kind of glossed over it, but here's now where I'm going to talk about it. It says here that we're undefined when x is 1. If I plug a 1 in here, I'm going to have an undefined value. Okay? It's a non-permissible value. That's where my reciprocal graph will never touch, because if I plug in an x is 1, my equation will be undefined. So that forms my vertical asymptote. It does that every single time. But you know what's also important to note? That's where my original crosses the x-axis. Okay? So let's go ahead and try a question. And it says, determine the equation of the vertical asymptote of the graph of 1 over 4x minus 3. So a vertical asymptote happens. Let's see if I can get this. Vertical asymptote is what makes the equation undefined. So that's all you got to find out. What would make 1 over 4x minus 3 undefined? Well, we can't have 0 on the bottom. Okay? So we're worried about what makes 4x minus 3 0. Oh, for Pete's sake. Man, I hope I get better. What makes 4x minus 3 0? So quickly just solve. How about we click that? Okay. So if I put that 3 to the other side and divide by 4, I'll get 3/4. Okay? So if I were to graph the line of 4x minus 3, I'd start down here at -3. My intercept would be at 3/4, and my line would look something like that. So if I wanted to graph 1 over 4x minus 3, this would be where my asymptote would be. And then my graph would go something like this and something like this, because my reciprocal and my original always cross over each other. Okay, we'll go over that more, but there's an idea of what's happening. Remember to pause. Pause during this this video recording if you need some time to catch up, or if I'm going too fast. Okay, so here it says that for all reciprocal functions, y cannot be 0, because there's nothing I can do that will ever make it 0. Okay, so for any function, since 1 over 1 is the same thing as 1, and 1 over -1 stays -1, any points where the lines are y equals 1 or y equals -1 intersect the graph of the original and lie on the graph of both the original and the reciprocal. Okay, that probably doesn't make a lot of sense, but here's a graph and maybe that will help. It says, for example, consider the graph of y equals 2x plus 3. That's in green. And then it's reciprocal, 1 over 2x plus 3, that's in red. Okay, so remember, we're going to have a vertical asymptote where my reciprocal is undefined. And so, if you have a look at 1 over 2x plus 3, remember I can't have that being 0. I can't have 2x plus 3 equals 0. So if I put my 3 to the other side, I can't have negative 1.5. Look at right here, negative 1.5. There's where not only my x-intercept of my original, but it's my non-permissible value of my reciprocal. That happens every single time that way, okay? So that's where that vertical asymptote comes from, where your original crosses the x-axis. And then look at my reciprocal. Look at how it goes down there. So I have a vertical asymptote at negative 1.5. I also have a horizontal asymptote of the x-axis because the x is y can never be 0. I can never have that. So it looks like this, and it looks like this here. And look at how it's crossing the original, okay, for the third time. That's going to happen every single time. But this business up here, we're probably going, what? Okay, this business up here is saying, hey, my original and my reciprocal are going to share the points where y is 1 and where y is negative 1. Because on my original, my output is 1. When I flip 1, I still get 1 over 1. On my original here, y is negative 1. But if I flip that, I'm still going to get negative 1. So it's saying that my original and my reciprocal are always going to share where y is 1 and negative 1. And that can help you graph them because it gives you a point that they're both going to go through. So it says, hey, both graphs pass through the ordered pair of negative 1 and 1 and negative 2 and negative 1. So that is helpful when you're graphing. And so let's have a look at that. So the second check your understanding says, let's sketch the graph of y equals 1 over x minus 3, and then we'll talk about domain and range, because of course we always have to talk about domain and range. So I'm going to give myself a quick x and y axis here, and what I have to do to graph 1 over x minus 3 is I have to start by graphing y equals x minus 3, because that's going to give me some points that will be helpful in my reciprocal. I'm going to graph it in green. Okay, so this is going to be graphed in green. So I'm going to start on the y-axis at negative 3. Hopefully visually, by looking at the equation, you can tell that my x-intercept will be 3, because to get my x-intercept, y is 0, and then just solve for x. Okay, and so my line is going to, I'm going to make it green. My line's going to look something like that. Okay, pretty handy sketching here on the SMART lesson. Okay, so that's x minus 3. Then I will graph in red 1 over x minus 3. My undefined value here, x could never be 3. Oopsie. X can't be 3. And look at how that happens to be my x-intercept of my original line. That's not a fluke. That happens every single time. This is where my vertical asymptote is going to be for my reciprocal. The last page just went on and on about how when y is 1 and y is negative 1, because those are the only two numbers that when you flip them or take the reciprocal of them, they're going to be exactly the same. You can put an ordered pair or put a dot on your original at 1 and put it where y is negative 1, because that's the exact point where your reciprocal is going to intersect your original. Because this is an asymptote, my reciprocal is going to hug it. It's going to flare out where y is 1, and then it's going to hug my x-axis. That was a good one. It's going to hug my y-axis, flare out at negative 1, and then hug my x-axis. And that's how you draw the reciprocal. You draw the original, you see where your vertical asymptote will be, where your x-intercept is. You draw your shared points at 1 and negative 1, hug the asymptote, go through negative 1, hug the horizontal asymptote, hug the vertical, go through that shared point of where y is 1, and then hug the x-axis. Okay? Every time. That's how easy it is. B says, what's the domain and range? Well, you kind of already know, because we've kind of already said what x and y can't be. The domain. Well, what can't x be? It can't be 3. So x can be anything but 3, if you want to put it like that. That's fine. The range. The only thing y can't be is 0, right here, right? We've got that horizontal asymptote at 0. So say that y can't be 0, but it can be anything else. And there you go, graph. Okay. This talks about the graphing calculator, which we don't use. And then the very last example of this lesson says, okay, here's the graph of the reciprocal. Use that graph to draw the normal function, okay, or the original, or the one that's not the reciprocal. So have a look. I've got my branch here on my right side. I've got the branch on the left side. It's telling you that the vertical asymptote is at -0.5, and you can see, hopefully visually, that I have a horizontal asymptote along my x-axis. So remember what my original and what my reciprocal share. They definitely share that point where y is 1. So go up here where y is 1 and go to your reciprocal and put a dot. Go down where y is -1, go over to your reciprocal and draw a dot. And then where did this vertical asymptote come from, if you remember? It came from where my original crosses the x-axis, or my x-intercept. So that's another point. And then you simply get a ruler, line them up. Let's make it blue. And that is my line. Of my linear function. And that's all there is to it. Okay, use the graph of the reciprocal to draw that linear function. Done. Okay, so I hope this was okay for you. I hope that you were able to follow along okay, and please ask me any questions that you need to in the next class that we have together. Thanks.